Hello everyone, welcome to Abdemi. I am Dr. Nandita and today I am here to solve some problems based on the concept that you have learned in the chapter hydrogen. But before I start, let's just talk a little bit about hydrogen. So hydrogen is having the simplest atomic structure among all the elements known to us or we can see around us, right? So basically hydrogen is having the atomic form. In the atomic form, hydrogen is having one electron and one neutron. However, in the elemental form, hydrogen exists as a diatomic molecule and it is basically known as dihydrogen, right? Hydrogen forms more than compared to other elements known to us, it forms more compounds compared to any known elements to us, right? And also it is highly important to know that hydrogen can be used as the energy source and the global concern regarding the energy can be overcome to a great extent by hydrogen, which can be used as the huge energy source. So hydrogen is of great industrial importance. Another interesting aspect about hydrogen is its position in our periodic table. So hydrogen is having the outer electronic configuration as NS1, right, or 1s1. So it is also similar or the electronic configuration resembles the electronic configuration of the alkaline earth metals of group 1. That's why hydrogen is showing similarities in properties with alkaline earth metals. At the same time, hydrogen is showing similarities in properties with halogens. Why? Because halogens are also having the outer electronic configuration as Ns2Np5 and hydrogen, which is also one electron lacking from the noble electronic gas configuration, that is Ns2Np6, and hydrogen is also having one electron less than the noble electronic gas configuration of helium. That's why hydrogen is showing similarities in properties also with halogen. Instead of the similarities in properties with halogens as well as alkaline earth metals, hydrogen has also some dissimilarities with them. That's why hydrogen is kept in a separate place in our periodic table. Now, with that, now let's move on to the problem. So, first problem is showing or asking that there are two equations we can see and there are some options given or statements given. We have to choose the correct option, right? So, one by one we will check for the two equations which is the correct option. So, option A is saying that H2O2 acts as oxidizing agent in equations A and B. You can see the equations here. Option B is H2O2 acts as reducing agent in equations A and B. Option C is H2O2 acts as oxidizing and reducing agent respectively in equations A and B, and option D is H2O2 acts as reducing and oxidizing agent respectively in equations A and B. So let's just see how can we solve this problem. So first of all, I will again write or rewrite the equation in order to comment on the statements given or in order to understand which one is the correct statement. So first of all, the first equation is HOCl plus H2O2 is giving you hydronium ion H3O plus Cl minus plus O2, right? So here HOCl undergoes reduction in presence of H2O2, right? So here the oxidation state of chlorine is +1 and here the oxidation state of chlorine is -1. So what is happening? There is a reduction in oxidation number of chlorine. That's why in chlorine. That's why we can say that H2O2 here in this equation acts as a reducing agent. Right? So for the first equation we have understood that H2O2 in this equation acts as reducing agent. Now let's check for the second equation. Right? So equation B, let's just write it down again. I2 plus H2O2 plus 2OH minus gives you 2I minus plus 2H2O plus O2. Here in this equation also iodine reduces to I minus. So this is also a process of reduction which is taking place in presence of H2O2 here. So here the oxidation state of iodine is 0, which gets reduced to -1 here. So iodine reduces to I minus. So the oxidation state of iodine changes from 0 to -1 or reduces, right? So this reduction process is also taking place in presence of H2O2. So what is the function of H2O2 in this equation? Here again H2O2 acts as reducing agent. So in both the equations H2O2 is acting as reducing agent. So if you now check the options given, you can see that option B is the correct option, which is saying that H2O2 acts as reducing agent in equations A and B. Simple. Now let's move on to the next one. Problem 2 is asking among statements A to D, 4 statements are given from A to D. We have to choose the correct ones. So statement A is saying decomposition of hydrogen peroxide gives dioxygen. Statement B is like hydrogen peroxide, compounds such as KClO3, PbNO3 whole 2 and NaNO3 when heated liberate dioxygen. And statement C is saying 2-ethyl anthraquinone is useful for the industrial preparation of hydrogen peroxide. And statement D is saying hydrogen peroxide is used for the manufacture of sodium perborate. Some options are given, we have to check which one is the correct option. Now one by one we will check from A to D which are the statements which are correct, right? So let's first start with the statement A, which is decomposition of hydrogen peroxide gives dioxygen. Let's just check. So decomposition of H2O2 gives you water and half O2. So we have as a product dioxygen. So we can say that statement A is a correct statement, right? Is correct. Now let's check for the statement B. Statement B is saying like hydrogen peroxide, compounds for example KClO3, PbNO3 whole twice and NaNO3 when heated liberate dioxygen. Let's check. So let's first check with KClO3. KClO3 when heated decomposes to KCl plus 3/2O2. So basically it generates dioxygen, right? Now if you check PbNO3 whole twice, when it is heated it will decomposes to PbO plus 2NO2 plus half O2. It will also generate dioxygen, as a product. The last one is NaNO3. When it is heated, it will generate NaNO2 plus half O2. So it will also generate dioxygen as product. So all the three compounds mentioned in the statement B are generating dioxygen as a product when heated. So we can also say here in this case that statement B is a correct statement also. B is also correct. Now let's check for the statement C. Statement C is saying 2-ethyl anthraquinone is useful for the industrial preparation of hydrogen peroxide, right? Now let's check. So first of all, I will draw the structure of 2-ethyl anthraquinone. So 2-ethyl anthraquinone looks like this. So this is our 2-ethyl anthraquinone. Now when it is reacting with H2, it will produce another compound which looks like this. And the name of the compound which it is generating is 2-ethyl anthraquinol. Right, plus O2. When it is reacting with O2, it will generate, or rather to say, it will regenerate the anthraquinone, 2-ethyl anthraquinone. So it will look again like this one. So it will look like this, or we can say that 2-ethyl anthraquinone is regenerated. And another product which will result in during this reaction is H2O2. So we can say that 2-ethyl anthraquinone is useful for the industrial preparation of hydrogen peroxide. So we can see that from 2-ethyl anthraquinone we can industrially prepare hydrogen peroxide via these reaction steps. So we can say that statement C is also correct. It's a correct statement. It's correct. Now one is left, that is the statement D, which is saying that hydrogen peroxide is used for the manufacture of sodium carbonate. Let's see. Now if I choose this place for the D, so if we use sodium metaborate, that is 2NaBO2 here with 2H2O2, it will generate Na2B2O4 OH whole 4. Now if you rearrange it, you will get Na2H4 B2O8, and this is nothing but sodium carbonate. sodium perborate, right? So from sodium metaborate, when reacting with H2O2 will generate sodium perborate, right? So if you check statement D is hydrogen peroxide is used for the manufacture of sodium perborate, we can say that statement D is also a correct statement. So statement D is also a correct statement. So what we have seen from this problem is that all the statements from A to D are correct statements and we have justified them properly. So now if you check the options, we can see that option B is the correct option, which is saying that A, B, C and D are the correct statements. So option B is the correct option for this given problem. So with this, I would like to end this short lecture. I hope you have understood and enjoyed. So get connected and get registered with Abdemi. Thank you very much. Have a good day. See you soon. Bye bye.